Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 3 for this week, and this one took some doing to produce. But I thought it would be interesting to take a look at the satellite temperature record and point out a couple of things about it. Now, up until late 1978, the only thing we had was a land-based record, and of course land only covers 25% of the planet. There were some observations over the oceans, buoys and ships and that type of thing, but certainly not the density that you would see over land masses. So the satellite obviously has an advantage in the sense that it's taking a look at the entire globe all the time, okay? And so you would expect that temperature record to be a little bit more accurate than basing it purely on land-based observations. So this goes back to late 1978, and this idea that I'm going to share with you today was actually given to me by Kevin Trenberth, who is a renowned scientist of the National Center for Atmospheric Research, and he talked about the fact that when we actually look at the temperature record, we tend to see a little bit of a stair step. And the reason that we see the stair step, at least to some degree, is the fact that you have natural cycles in the atmosphere, which are very observable if you look back, through the temperature record. There's no question that there is natural variability in the temperature record of the planet, okay? So then what you have to do if you're looking at climate change due to greenhouse gases, you've got to try to separate out that natural variability and then see what you've got left. And that is no easy task to do that, okay? But I wanted to use a very, very basic and simple example today to illustrate how such a pattern can come about. And so that's what we're going to do now. So let me go on ahead and put myself down here in the corner. And here we go. Now, I'm going to allow a sine wave, okay, to represent the natural variability in the atmosphere. So you have periods of time where it gets warmer, periods of time where it gets colder, warmer, colder, and so forth, okay? Now, I'm going to superimpose on that a linear function, which is going to represent the steady increase in greenhouse gases, which is very, very easy to document. There is a station out in Hawaii that has been looking at this since 1950, and there's no question that those gases are increasing and that we are doing that, okay? So you've got a sine wave, the natural variability, and you've got the linear function representing a steady increase in the amount of greenhouse gases. Not just CO2, but methane, nitrous oxide, and the whole bit. Okay, now when you add those two functions together, look what you get. You get a period of time where it's increasing, and then it levels off. And then you have a period of time where it increases, and then it levels off. And then it begins to increase again. So this is your basic stair-step function, okay? And if you'll recall, back in the early 2000s, there were some people that were claiming, oh, global warming has stopped, okay? No, it hadn't, and you can't take any period of time shorter than 30 years and do any reasonable evaluation of any climatic trend. This is why the normals, the 30-year average, is based on a 30-year period, because anything short of that, you're going to get these oscillations up and down, and you're going to think, oh, this is the beginning of a trend, and it's not, okay? Or not necessarily. So what you have to do is look at long periods of time. And so here's the illustration of how you would get that stair step. So let's take a look now at actual data. And I want to point out that Roy Spencer and John Christie at the University of Alabama at Huntsville are true pioneers in terms of developing a system where you could use satellite to estimate global temperatures, okay? Now, both of these gentlemen are on record as saying that, yes, they acknowledge that man is warming the climate, they just don't happen to think it's all that big of a deal, okay? And I think I'm representing their point of view accurately there. And I actually went down to the University of Alabama in Huntsville and interviewed John Christie when we did the documentary on climate change at WRAL several years ago. And he was very honest about the fact that he just, doesn't think it's a big deal, but he acknowledges that, yes, man is warming the climate. So I say that because if there's any data set that is not going to be exaggerated for the purpose of trying to convince you that climate change is a big deal, this is it, okay? If they thought that we were going to head toward a catastrophe, they might be tempted to augment this data a little bit, but they don't think that, and so this is the actual data that they are observing, okay? There's no reason to think that this is being inflated at all, okay? Now, here's the record. What I did was I wanted to go back and split the last 40 years into equal 10-year periods, okay? So we're starting off June of 1984 and we're ending in May of 2024. Obviously, lots of ups and downs, but if you put a linear trend line on that data, that red dotted line there is what you get. And if you remember back to your math days when you were plotting graphs, do you remember the slope equation that y equals mx plus b? And the m, the letter there before the x, that's the slope of the line, okay? So the bigger the slope, the steeper that line's going to be. So the overall trend over the last 40 years has a slope of 0.0014, okay? Now, let's split this up into 4 equal 10-year periods. Now here you have the first 10 years, and the slope is positive, but it's not as positive as the overall slope, okay? It's actually cut in half. 0.0014, that first 10 years is 0.0007, okay? Now, let's move to the second 10-year period. And graphically, it may not be that terribly obvious, but the slope of that second 10-year period doubles and is basically the same thing as the overall trend, okay? So not that much of an increase and then a bigger increase, okay? Now, let's go to the third 10-year period. Almost no change at all. The slope is 0.0002, okay? So we go from not so much of a slope to a bigger slope to no slope. And then the last 10-year period, the slope is huge, 0.0029. Now, in all fairness, the reason that that slope is so big is that we just had a strong El Nino, okay? And that's why you see this spike out in here. And so again, as I mentioned earlier, you can't take a look at a 10-year period and discern an overall climatic trend. And so if you were to add, another 10 years onto that and we don't have an El Nino that big, then that slope's going to come down. But the overall pattern here is obvious, where this is our overall slope up here. We have a small slope, a bigger slope, no slope, bigger slope, okay? The basic idea is we've got a stair step here. It doesn't, go from big to zero, but certainly the trend is the same thing as a stair step function. So it's not surprising that we would see periods of time where we wouldn't see any substantial warming, and then over the next 10-year period, then it would go up again, and then it would level off, and then it would go up again. So again, you look at the long-term trend, which is definitely up, but there are natural variations in our climate that are independent of any human activity. And then we superimpose the human activity on top of that, and this is how we end up with what you're seeing here, okay? So I just wanted to show you that so that you know that I am acknowledging the fact that the atmosphere does have its ups and downs on its own, that it's had ever since day one, okay? And then the trick is to try to subtract that out and then see what you have left. And there's no question that the overall long-term trend is up. Okay. All right, that is bonus weather video number 3 for this week. Hope you found that interesting. The next one will be coming up on Monday, next daily weather update on Monday as well. And if there is any severe weather that breaks out on Sunday or the threat increases or anything like that, I will do some posting on Sunday, at least in a text format, to let you know what's going on with that. So just keep a cautious eye to the sky and keep up with the latest warnings and watches and all that kind of stuff. All right, that's it for now. You all have a wonderful Friday evening and even better weekend, and we'll talk to you again on Monday. Take care.